Hi there. In this video, I'll show you how to quickly compute the measures of central tendency, i.e. the mean, median, and mode for three common data series types. This video is divided into three parts. In the first part, we'll cover the individual series data. In the second part, we'll cover discrete series data. And in the last part, continuous series data. We'll be using three different data sets which will be introduced as we go along in the video. Throughout this video, we are going to be using common statistical notation. So remember, the mean is usually denoted by x bar, the median by m, while the mode is by the letter z. This video is about 25 minutes long, so I've placed timestamps below so you can skip to any part of the video quickly. Alright, let's do this. This is the data set of the number of vaccinations per child that a sample of 9 children received in Samaru's area. This is an individual series data because each number here represents the data from one child. Let us find the mean of this data. Recall that we said that the arithmetic mean is a measure of central tendency that indicates the average value of the data set. So our task here is to simply find the average. The mean of an individual series is given by the formula. X bar is equal to the sum of the values in the dataset from the first value to the nth value or the last value of x divided by n. Here, x bar represents the mean of the sample. Sigma I equals to 1 to n is the sum of all the values from the first to the last. X sub I is the index dataset value and n is the number of values or the size of the sample. So let us use this formula to find the mean of our dataset of the 9 children. So all these data values represent our x sub I, and our summation x sub I will then be the sum of all these data values. So we simply sum all the values together to get our numerator. And then we divide by n, the number of values, which is 9. And this will be 25 divided by 9. And so our mean is 2.7. Easy peasy. Let's do this. Median of individual series data for odd number of data points. This is the data set of the number of clinic visits in the last year of a sample of 9 children in Samaru's area. This is an individual series data because each number here represents the data from one child. Let's find the median of this data. Remember that we said the median is a measure of central tendency that indicates the middle point of a data set. So our task here is simply to find the middle point. To do this, we need to first arrange the data in ascending or descending order. I prefer the ascending order because it's just logical. So here we'll have 0, 1, 1, 1, 3, 3, 4, 5, and 7. That is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So our number of data elements n is 9, and this is an odd number. Awesome. Now, because our data values are already arranged in order, it will be easy to pick out the middle value. All we need to know is its position. Well, there is a simple formula for this. The median position is given by n plus 1 divided by 2. Notice that there is a th up here. This means that whatever we find here is just the position of the median and not the median itself. So the median position will be n, which is 9, plus 1, all divided by 2. That's 10 divided by 2, which will give us 5. So our median is going to be on the 5th position. Awesome. So let's count. 1, 2, 3, 4, 5. And the value of our median is 3. Easy peasy. Now we can also do this using another method if the data set is not too large. I will not advise you to use the second method I'm about to show you if you have more than 20 data points in your data set, because that's too large and it may be unwieldy. I call this method the quick method. So as usual, we'll first arrange in ascending order, and since the median is the middle number and at the median value, half of the data values will lie below and the other half will lie above the median, right? So we can cancel out from each end to find out which data value is left in the middle after cancelling equal numbers from both sides. So let's cancel the first and the last, and then the second and the second to the last, and then this, and then finally this and this. And here you can see that our middle number is 3, and that's our median. Awesome. Now what happens when our data set is an even number of values? How to find the median for individual series data with even number of values. This is the individual series data of the number of times that 10 children were vaccinated in their lifetime. Let's find the median of this data. Recall that we said that the median is a measure of central tendency that indicates the middle point of the data set. So our task here is to find the middle point, right? To do this, we need to first arrange the data in ascending or descending order. I prefer the ascending order because it's just logical. So here we'll have 0, 1, 1, 2, 2, 3, 3, 4, 5, and 5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Awesome. So our number of data elements is 10 and this is an even number. Awesome. To find the position of the median value, we will use the same simple formula that says the median position is n plus 1 divided by 2. Notice that there is a th here. This means that whatever we find is the position of the median, not the median itself. So the median position will be n, which is 10 plus 1, all divided by 2. That's 11 divided by 2, which will give us 5.5. So our median is going to be in this position. Well, guess what? There is no 5.5 position. So we'll have to find the average of the values at the 5th as well as the 6th position. So let's count 1, 2, 3, 4, 5. So our 5th value is 2 and our 6th value is 3. The average of 2 and 3 is just 2 plus 3 divided by 2, and that will be 2.5. So our median is 2.5 kg. Easy peasy. Now we can also quickly do this using the quick method if the data is not too large. So since the median is the middle number and at the median value, half of the data values will lie below the median value and the other half will lie above the median, right? So we'll need to first arrange this data in ascending order because that's the logical thing to do. And then we'll simply cancel from each end to find out which is the median or which is the median number. So let's cancel the first and the last. Let's do the second and the second to the last. Then this, and finally this and this. And guess what? We're left with two numbers. All right. So we will just find the average of 2 and 3 and get the median, and that will be 2.5. So our median is 2.5 kg. Easy peasy. Mode of individual series data. This is the data set of the number of vaccinations per child received by a sample of 9 children in Samaru's area. This is an individual series data because each number here represents the data from one child. Let's find the mode of this data. Recall that we said that the mode is a measure of central tendency that indicates the most frequent value of the dataset. So our task here is simply to find the most frequent value, right? To do this, we need to first arrange the data in ascending order so we can see all the same values together. Next, we observe to see which value has the highest frequency. For the first value, 0, it occurs only one time. For the second value, 1, it occurs 3 times. 3 occurs 2 times, while the fourth, fifth, and sixth values each occurred only once. So we can see clearly that the highest frequency is 3 and the value with the highest frequency is 1. So the mode number of visits is 1 visit. Easy peasy. In this video, I will show you how to quickly compute the mean, median, and mode, essentially the measures of central tendency for discrete series data. We will be using this discrete series data set of the number of dental clinic visits for 10 children in Samaru's area, Nigeria. We are going to be using common statistical notation, so remember, the mean is usually denoted by X bar, the median by M, while the mode is by the letter Z. I've placed a link above if you want to learn how to compute these same measures for continuous series data. I've also placed timestamps below in case you want to jump to any portion of this video. Alright, let's do this. The mean of discrete series data. This is a discrete series data set on the number of dental clinics of a sample of 10 children in the last 1 year. We know that this is a discrete series data because we can see the variable and the corresponding frequencies, right? So how do we find the mean of this data? Recall that the mean is a measure of central tendency that indicates the average of the data set. So our task here is to find the average. Let's first modify the table a bit to make it easy for us to compute the mean. So let's put the number of visits here and the frequency here. And then we have all the data arranged neatly in a vertical manner, like so. Better. The mean of a discrete series dataset is given by the formula. X bar is equals to sigma from I equals to 1 to n of f sub I multiplied by x sub I divided by sigma f sub I. This means the sum of the product of each frequency and each value in the dataset from the first value to the last value of x, all divided by the sum of all the frequencies, which is the same as the number of values. Here, x bar is the symbol for the mean of the sample. Sigma I equals to 1 to n is the sum of all the values from the first to the last. F sub I is the value of the ith frequency, i.e. the frequencies of the index data values. X sub I is all the index data elements. And sigma f sub I is the sum of all the frequencies, which is the same as the sample size. So let us use this formula to find the mean of this data. First, let's label our table with the correct statistical notation to enable us to easily apply the formula. So our number of visits is our data value. And let's label this as x sub I and the frequencies as f sub I. And since the numerator of the formula wants us to find the product of f sub I and x sub I. Let us create a new column now to do the product of the frequency and the values of x. Let's call it f sub I of x sub I. So this will be 0 times 1, which is 0, 1 times 3, which is 3, 2 times 3, which is 6, 3 times 2 is 6, and 5 times 1 is 5. Awesome. Now going by the formula, we need to sum all of these to get the sum of f of x, which is our numerator. Adding all this together, we will have 20. Now the denominator for the formula is the sum of the frequencies, which is 10. The question even says that we have 10 children, right? Awesome. So our mean is 20 divided by 10, giving a mean of 2. Easy peasy. The median of discrete series data. How do we find the median of this data? Recall that the median is a measure of central tendency that indicates the middle point of the dataset. So our task here is to find the middle point or the middle value of the dataset. Let's first modify this table in a bit to make it easy for us to compute. So we'll put the number of visits here and then the frequency here, and then we can put in all the data arranged neatly in a vertical manner. To find the median for discrete series, we will need to first compute the cumulative frequency. So let's just create a new column here, and we'll call this cumulative frequency, and this will be 1, and then the next will be 1 plus 3, so the cumulative frequency is 4, then 4 plus 3, and this is 7, 7 plus 2 is 9, and 9 plus 1 is 10. Awesome. So to confirm if your cumulative frequency calculation is correct, the last cumulative frequency should be the total of all the frequencies. So we can see here it is 10, and here too we have 10. Awesome. And when we add all the frequencies, we confirm the information that we have in the question that says we have 10 children, right? Remember, the question says we have 10 children. So our n is 10. Great. The formula for locating the median position is n plus 1 divided by 2. Notice the th here because the formula just gives us the position. So the median position is 10 plus 1 divided by 2. That's 11 divided by 2, giving us the 5.5th position. Now we know the position of the median. Next, we will need to locate the median value. To do this, we'll also use the cumulative frequency. The median is going to be at the cumulative frequency value, which is just above the median position. So if we look at the cumulative frequency, the one just above the 5.5th position is 7. So we'll just trace this back to our original number of visits, and we see that our median number of visits is 2 visits. Easy peasy. The mode of discrete series data. So how do we find the mode of this data? Recall that the mode is a measure of central tendency that indicates the most frequent value of the dataset. So our task here is to find the one with the highest frequency. When we look under the frequencies, we see that the highest frequency is 5, and the value with the highest frequency is 1. So our mode number of visits is 1. Easy peasy. In this video, I will show you how to quickly compute the measures of central tendency for continuous series data. This includes the mean, the median, and the mode. We will be using this continuous series dataset of the weights in kilograms of 10 children attending the nutritional clinic in Samaru Zaria, Nigeria. We are also going to be using common statistical notation, so remember, the mean is usually denoted by x bar, the median by m, while the mode is by the letter z. You can check out the link above if you want to learn how to compute these same measures for discrete series data. I've also placed timestamps below if you want to quickly skip to any part of this video. Alright, let's do this. The mean for continuous series data. This is a continuous series data on the weight in kilograms of 10 children attending the nutritional clinic in Samaru Zaria, Nigeria. We know this to be a continuous series because we can see that the data is grouped and the frequency for each class is provided. So how do we find the mean of this type of data series? Recall that the mean is a measure of central tendency that indicates the average value of the dataset. So we'll be looking for the average value, right? Let us modify the table a bit to make it easy for us to compute the mean. So let's place the weights in kilograms here and the frequency here. And then we have all the data arranged neatly in a vertical manner like so. Awesome. The mean of a continuous series dataset is given by the formula x bar is equal to sigma from I is equal to 1 to n of f sub I multiplied by m sub I divided by sigma f sub I. This means the sum of the product of each frequency and each midpoint from the first class to the last class, all divided by the sum of all the frequencies, which is the same as the number of values. Here, x bar is a symbol for the mean of the sample. Sigma I equals 1 to n is the sum of all the values from the first to the last. F sub I is the value of the ith frequency, i.e. the frequencies of the classes. M sub I is the index midpoints of the classes. And sigma f sub I is the sum of all the frequencies, which is the same as the sample size. Great, now let's apply this formula. First, let's work on the numerator. So we'll first find the midpoints, then multiply each midpoint by the respective class frequency, and finally sum all of them together. So let's find the midpoints. To do this, we'll add the lower and the upper class limits of each class and then divide by 2. So for the first class, it will be 0 plus 5 all divided by 2, and that's 2.5. For the second, it is 5 plus 10 all divided by 2, and that's 7.5. Next is 10 plus 15 all divided by 2, and that's 12.5. And then 15 plus 20 divided by 2, and that's 17.5. And lastly, 20 plus 25 all divided by 2, and that's 22.5. Nice. Now that we have all the midpoints, our next step will be to find the product of the frequency and the midpoints of each class. So let's create another column here and label it f sub I times m sub I. So here for the first class, we'll multiply 1 times 2.5, and that's 2.5. For the second class, 3 times 7.5, and that's 22.5. Here 3 times 12.5, that's 27.5. 2 times 17.5, and that's 35. And lastly, 1 times 20.5, and that's 22.5. Awesome. Now that we have all the products of the frequencies and midpoints, we just need to sum them to complete the numerator. So the sum of the product of the frequencies and the midpoints of each class, that's the sigma f sub I of m sub I, is equal to 2.5 plus 22.5 plus 27.5 plus 35 plus 22.5, and this equals 110. Awesome. Then we go to the denominator, which is the summation of f sub I. This is the total of the frequencies, and this is actually the same as the total number of children, or our sample size. So we say 1 plus 3 plus 3 plus 2 plus 1 all equals 10. Remember, the question even said 10 children, right? Awesome. Now we have both our numerator and our denominator. So our numerator is 110 divided by our denominator 10, and this will give us 11 kg. So our mean weight is 11 kg. Easy peasy. So this is how to easily compute the mean for continuous series data. Median for continuous series. This is a continuous series data on the weight in kilogram of a sample of 10 children attending the nutritional clinic in Samaru, Zaria, Nigeria. We know this to be a continuous series because we can see that the data is grouped and the frequency of each class is provided. So how do we find the median of this type of data series? Recall that the median is a measure of central tendency that indicates the middle value of the data set. So we're looking for the middle value or midpoint, right? Let us modify this table in a bit to make it easy for us to compute the median. So let's put the weights in kg here and then the frequency here, and then we arrange all the data in a vertical manner. Awesome. This is better. To find the median for continuous series data, we will need to first compute the cumulative frequency, just like we did for discrete series data. So let us create a new column here for cumulative frequency. This will be 1, then 1 plus 3 is 4, then 4 plus 3 is 7, then 7 plus 2 is 9, and then 9 plus 1 is 10. So to confirm if the cumulative frequency is correct, the last cumulative frequency should be the total of all the frequencies. So you can see here it is 10 and here too is 10. Awesome. And when we add all the frequencies, we confirm the question that says we had 10 children. So our n is 10. Great. So first, we need to find the position of the median class. To find the position of the median class, we will use the formula n divided by 2. So we will do 10 divided by 2 to get the median class position. So this is the 5th position. Nice. Next, we locate the median class using the cumulative frequency. The first observation lies in this class, as we can see a frequency of only 1. Then the next 3 observations lie in the second class, alright? That's already 4 observations, right? But we are looking for the 5th observation. And the 5th, 6th, and 7th observations all lie in the class of 10 to 15 kg. So this is our median class. Great. Let's pay special attention to this class, its frequency and everything. Now, if you don't understand how we got this class as the median class, an easy way to look at it is that you should just select the class that has a cumulative frequency just above the median position. So our cumulative frequency of 7 is the one just above the 5th position, right? Nice. Now we know our number of values to be 10. and the median class position to be the 5th position. Now we know the median class to be the 10 to 15 kg class. Now let's go ahead and find the median value. To find the median value, we'll make use of the simple formula L1 plus N over 2 minus CF0 divided by F1 multiplied by H, where L1 is the lower class limit of the median class, which is 10. F1 is the frequency of the median class, which is 3. CF0 is the cumulative frequency of the class preceding the median class, which is 4, right here. H is the width of the median class. The width is the lower limit of this class minus that of the preceding class. So that is 10 minus 5, so we have 5. So our median is going to be 10 plus 10 divided by 2 minus 4 divided by 3 multiplied by 5. So this is 10 plus 5 minus 4 divided by 3 multiplied by 5. That's 10 plus 1.67. Our median equals 11.67 kilograms. And when you look at it, the median class is 10 to 15 kg, right? And our median falls somewhere in between this interval. So this is how to easily compute the median for continuous series data. Mode for continuous series data. This is a continuous series data on the weight in kilograms of 10 children attending the nutritional clinic in Samaru Zaria, Nigeria. We know this to be a continuous series because we can see that the data is grouped and the frequency for each class is provided. So how do we find the mode of this type of data series? Recall that the mode is a measure of central tendency that indicates the most frequent value. So we'll be looking for the most frequent, right? Let us modify this table a bit to make it easier for us to compute the mode. So let's place the weights in kg here and the frequency here. And then we have all the data arranged neatly in a vertical manner like so. Awesome. The mode of continuous series data is given by the formula Z equals L plus open parenthesis F sub 1 minus F sub 0 divided by 2 times F sub 1 minus F sub 0 minus F sub 2 close parenthesis multiplied by lowercase h. Here, Z represents the mode, L is the lower limit of the modal class, F sub 0 is the frequency of the class preceding the modal class, F sub 1 is the frequency of the modal class, F sub 2 is the frequency of the class succeeding the modal class, and H is the size of the class interval. So let us apply this formula to find the mode of this data. First, we need to identify the class with the highest frequency, and this is called the modal class. The highest frequency is here, 7, right? And this belongs to the 5 to 10 kilograms weight class. So this is our modal class. And so the lower limit of the modal class, L, is 5. The frequency of the modal class, F sub 1, is the highest frequency, and we already know that to be 7. The frequency of the class preceding the modal class, F sub 0, is 1, and the frequency of the class succeeding the modal class, F sub 2, is 3. And the size of the class interval, H, is... So if we're using the modal class, the lower limit of the next class minus the lower limit of this class will give us the size of the class interval. That will be 10 minus 5 equals to 5. Awesome. Now let's plug in all these values into the formula. So Z equals L, which is 5, plus open parenthesis F sub 1, which is 7, minus F sub 0, which is 1, divided by 2 times F sub 1, which is 7, minus F sub 0, which is 1, minus F sub 2, which is 3, then close parenthesis, and finally multiplied by H, which is 5. Great. So we'll have 5 plus 6 divided by 10 multiplied by 5. That will be 8. So our mode is 8 kilograms. Easy peasy. So this is how to compute the mean, median, and mode for continuous series data. Now, if you've gained value with this video, please give this video a thumbs up and share with your friends and colleagues to help them. And if you want to see more awesome statistical videos like this one, consider subscribing to this YouTube channel. Now, if you want to learn how to compute the median for different series data, check out this video here. And for the mode, check out this other video right here. See you in the next video. And as always, thanks for watching.